So good morning, good afternoon. Today we are evaluate for Slb Project new project about new techniques for capture hydrogen, and also we evaluate some troubleshoot about the way to capture and the way to make security wells and have geomechanical stability. So, and also improve and have a good hydrogen diffusion through the cementing with the new type of cementing with the fiber reinforcing cementing. So the simulation is, in this case we are simulated the flow through the cementing and the color. This is simulation is a simplified steady state 1D diffusion model based on the first and Frick first law, the effective coefficient without assumption, and the hydrogen flux that is named J is the leakage rate per unit is calculated in this way. The results summary: current cement thickness and required cement thickness for target leakage rate, the concentration profile cement. This plot illustrates the steady state hydrogen concentration decrease linearly from inside boundary to the outside boundary of the cement shelf. So we have the steady state hydrogen concentration profile through the cementing system, and instead of distance from inner cementer systems. So when you have a distance measured at 20, you try to have a zero concentration of hydrogen. So is a way also to estimate the thickness of the cementing and how many fibers of glasses you need in this case to have a good diffusion of hydrogens through the cementing and in the wells. So the cumulative hydrogen leakage over time. This plot shows the cumulative mass of hydrogen that would leak out over the specified duration, assuming a constant steady state leakage rate calculated by model. So in this case we have a cumulative hydrogen over time, and you have the cumulative hydrogen over time in steady state assumption. You calculate hydrogen leakage in kilos kilos by hour. So after, for example, 500 hours, you have this value of hydrogen leakage in kilos is 0.8. So that means around 18 grams. This is not, so we are evaluating this reservoir, but we need to simulate this model. Model limitation and consideration. We have 1D diffusion model, consider only the one-dimensional radial outwards. The real well bores involves complex 3D fluid and diffusion path, the steady state assumption for flux, the primary diffusion calculation, and the cumulative hydrogen leakage plot, then extrapolates this constant rate over the selected duration. We are using a transient equation diffusion, the fixed second law, and we idealize fiber effects, and we don't have a non-geomechanical reaction. So about the wellbore complexity, it simplified the wellbore geometry and does not include other potential leakage. The hydrogen behavior, assume hydrogen concentration, the hydrogen behavior we assume in concentration expressed in mole by meters cube. In practical application, hydrogen partial pressure and solubility in cement pore water was be accurate parameters to consider. For a real-world hydrogen cementing project, a much more sophisticated multiple physics model considering fluid mechanical stress, geomechanical reaction, and transient behavior. This sketch is purely intended to sketch for a first phase of exploration, understanding the basic principle and evaluate the cost of eventual project. And so is an interesting new application of wave to cementing and make safety wells and have improved the production.